Yo, 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 yo. Yo, what up? Is this thing on? Okay, cool. Looks like it's on. Neato. All right. Welcome to the stream. For those of you that are returning and those of you that are new. How's everyone doing? Good, I hope. So, I'll give a couple minutes for people to show up, and I'm gonna make a post real quick. And also, let's see if this works without my system crashing. I don't know if I've completely fixed that. I think I have, but who knows? We'll see. Do. Sorry, I'm just doing some extra setup stuff. Yeah, if you can see, I put a poll out on YouTube to see what people wanted to watch next, or what they were interested in next. And I've got this it's like a Ring camera. If I can get the battery out. Well, of course not. There we go. So it's a Ring security camera. This is just a spare one that I had lying around, and I wanted to take it apart and see what it's doing and what's going on under the hood, and kind of check it out. You know, the usual stuff. Take it apart, reverse engineer it, figure out how it works. So that's what I've got planned going on. I don't know a whole lot about these devices. I did a little bit of cursory reading, and some people are able to, like, with some of the other Ring devices, dump some firmware and stuff, so that sounds kind of fun. Get access to, like, the file system or something. Would be kind of interesting. So we can try that out later. Let me get this post going, and then we can start doing a little bit of research and figure out what this thing is up to. All right. Okie dokie. So let's go ahead and see if we can figure out some information about this thing. It looks like there's a regulatory label on the inside of this, but I got to get it out of the case. So let me do that really quick. No, of course that one's not gonna work. 1 second. And if you guys wanted to look up more information about this thing, this is the Ring Stick-Up Cam. In fact, while I'm taking this apart, I can do that. Let's see. Now, let me turn off my proxy. Oops. Let's see, no proxy. All right. Just doing some man in the middle stuff. Let's see, teardowns. All right, so this is what we're working with. We can follow through or follow along with this. All right, take those off. Screws on the back too. Oh no, I don't need that. There's screws down at the bottom. No, this looks different. So this is probably a different model. May need to do that. I don't know. We'll see. Yeah, let me go get my spudger, actually. This might do the trick. No? Okay. All right, 1 sec. Let me go get a spudger. Try not to slice myself on this thing. I hate this stuff. I hate it when they have like stupid plastic. Just give me screws. Give me bare screws. I don't care. I don't care if I see bare screws on my hardware. Give me bare screws. Bare grills? No, bare screws. God, jeez. I hope this is how you're supposed to get this thing open, because I am totally tearing it up. Oh, there's like a rubber grommet around it. Yeah, I don't know. Let's see. I could just be doing this all wrong. Yeah, because this is a different model. Do 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 do. Yeah, this is what I was just looking at, right? Boop boop doo doo boo. Yeah, see, my silver latch isn't like that. I don't have a silver latch like this. So, this is a little bit different. We're on our own. This is uncharted territory. Well, uncharted by iFixit. And I don't know what model or revision this is to look that up, but maybe just push it down and out? No, nope, that's not how. Maybe you hit it with a hammer. Maybe that's the trick. You gotta hit it with a hammer. Yeah, I was damaging the plastic vacant somewhere with the screwdriver. Jeez. See if I get a look at this model number that's in here. I think it is SUM 7ES. And that looks to be about right. Second gen. Okay. Let's see. Stick. Second gen. Tear down. Let's see how they get through this stupid top. Yeah, it's the wrong one. Okay. Ah, yes, a camera. I don't. What do you think? I don't think Tech Radar has an actual teardown, do you? No, of course not. Okie dokie. I'll just break it. This is like a double spudger situation. You guys ever have those double spudger situations? Yeah, I'm just tearing it up. Look at that. That's incredible. Um, hmm. Let's see if we can get an FCC ID, maybe? You know, I could just tear this whole ass sticker off. That'll get me some information without having to destroy more of it, at least. Unless the sticker gets damaged. And then I ruin the regulatory info. Okay. I think. See, I'm trying to get that sticker on the inside. Thankfully, it's a nice plastic sticker instead of like some paper one that would have ripped just a second ago. Oh, I just had to say something, right? Okay, cool. There we go. Just gonna stick this on the back of the device where I can actually read it. Okay. All right, so that's our regulatory info. And let's check that out online. Okie dokie. So we've got. Where is our FCC ID? That's my favorite. I like FCC IDs. They're kind of my go-to. But real quick, let's write down some label details. 5UM, oh, it's a 5, not an S. Okay, well that makes sense. 5UM 7E5, 7E5, FCC ID is 2. AEU as in uniform, P as in Papa, B as in Bravo, H as in Hotel, A as in Alpha, S as in Sierra, C as in Charlie, 071. And we have a Canadian IC number. Now those can also be useful. That is a 20271 dash Bravo Hotel Alpha Sierra Charlie 071. Okay, and let's see. Power. It's 5 volt. And let's see. 2.5 amps. Cool. And MAC address. Let's get the MAC address. I've got a 118 colon 7F colon 88 colon echo echo colon 28 colon 09. All right. Cool. So I think that's about all we get off of that. Here, I'll see if I can get this so you guys can look at it. There, if you want to punch that stuff in yourself and, you know, follow along, you're more than welcome to. So let's see, let's get the FCC ID, because I like that one. I'm going to save our juice, because that's good. Some good juice. FCCID.io. And I'll drop that bad boy in there. Ooh, it's the stick-up cam light. Okay. Cool. All right, internal photos. Let's get them. External photos. Get them. Test setup. All right, download PDF. Desktop. Perfect. All right. And let's see, download PDF. Do, 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 do. Photographs of the test configuration. I'm just going to save these, that way I don't have to keep coming back to the FCCID.io database. Oh, look at those blocks. Beautiful blocks. Wow, the ray gun. Captain, hit it with the ray gun. Okay. Okay. And let's go ahead and browse to our thingamabobber. Open these up. Let's take a look at these. Actually, I'm going to open them in Firefox. Okay, cool. Let's scroll through these. How do they get this sucker open? Right? This thing peels open. What? What the ain't no way. They're crazy. What the hell are they talking about, man? Yeah, this is clearly a different plastic housing. Well, that's fun. Well, there's your power board. That's what our internal PCB looks like. Got a handful of unpopulated headers. Yeah, populated headers. Those are interesting. See if any of these headers are populated. There's our crystal oscillator, I believe. That's our CCD, the actual sensor. I guess that's another sensor. Probably infrared, maybe? What is that? X-Lite S? No idea. It's the back side of our board. We've got a SAV20 ARM processor. No idea what this is. Let's get some of this stuff written down. Alright, so our chip deets. We've got a SAV20, and this may actually be different when we get into the device itself. But we'll write it down. 42B. 2115J. SAV20-Y01 AB10D42B. Then we got a MediaTek MT7686DN 2116 AFAL. I think this might be like our flash chip or something. Maybe. Or the MCU. And MCU. No idea. We'll find out later. Oh, this one's real snotty. It looks like they conformally coded it. Is that like A5283 something or another? Okay. Second source component. Oh yeah, this one's less snotty. Different photos. Less snotty. I think. Yeah. That's what they were like, hey, you can't send us those snot videos or those snot photos. We need photos with less snot. Otherwise, we're gonna deny your regulatory application. Okay. Let's check external photos. Yeah, different model. Pretty sure. Slightly. The hardware on the inside might be the exact same, but I wonder if they just changed the way the case works to make it harder to get into or something. I don't know. Who knows? Let's try to get this open. I'll try working my spudger around the outside. I don't know. Maybe it gets pushed out this way or something. Oh, I tried that. I don't think it does. The inside right here seems to have like its own like internal layer, like this whole structure comes out. But how? I have no idea. Probably some sort of secret. It's always some secret. All right, I'm gonna go get the box of spudgers. This requires the box of spudgers. Well, that's unfortunate. I have seemed to have misplaced my box of spudgers. Um, I might have to go find them and dig them up. Hey, what's up, Zoni? It's mostly by myself. I got into cybersecurity working for a company, but it wasn't doing reverse engineering or hardware stuff. But that's mostly been my favorite thing, is taking apart hardware and software, so I kind of do it on the side and learn as I go. But let me send you guys to the idle room really quick, and I'm gonna go dig up my box of spudgers, because that's kind of important at this moment. Be right back. Okay. Well, unfortunately, my box of spudgers is gone. So I will deal with finding it later, but I did find my favorite spudger, which is this one. So I will try this, and if that doesn't work, then we will try other methods of understanding this device without breaking it open, because you don't always have to take something apart to figure out how it works. And that might actually be interesting to learn. But I like taking things apart, so that's what I'm going to do, if I can. Just take it apart. Alright, I'm going to stop before I slice my finger open live on stream. So, let's go ahead and we will do we can do the setup. So I've got a burner Android phone here, and I got the Ring app set up on it. So let's go ahead and get that going. We'll set this thing up, and we'll just we'll see if we can man in the middle of it or something. In fact, actually, let me get the other piece of hardware that I need. Okay. Yeah, that's a good point. Drill in some holes to get in. And it's not broken if it still works. That is true. You're just messing up and damaging the external housing, which is fine. You can paint over that, right? The hardware still works. Don't mind this you know, a little bit of rubber gasket that keeps water out. It's still fine. um so let's see. Let me get this. I've got this turned on, my little Wi-Fi hotspot. Let me see if we can get this connected. Probably should have done all this pre-stream, but whatever. That's a good question. I really want to get to the file system. That's kind of one of my favorite things to look at on these devices, especially if they're running like some sort of embedded Linux. So I like to look at the file system and see what kind of juicy things are sitting around there, like certificates, passwords, configuration files, that kind of stuff. That's all interesting to look at to me. So I would really like to get to that. There's a number of ways to get to that kind of stuff that we can try to use, but I don't know how far we'll get today before I run into some walls or end up having to go do something else. But I'm plugging up some Ethernet cables right now to my little testing router. Okie dokie, and let me get this hardware pass through. All right, add our NIC. Which one is it? Oh, geez, I gotta be careful. Wait, which one am I using? Oh, okay. I think SSH in and check. Yeah, sorry you can't see all this. This is all occurring outside the virtual machine. Just checking the NIC on my host so that I can pass it through to the VM. IP ADDRSH. It's 10G0. Okay, so F1. Ethernet 1. That is the one that we need to add. PCIe host device. And we're going to go down here to interface Ethernet 0, Ethernet 1. That one. Intel Corporation. All right, let's see if it picks it up. Over here on the VM, we should see. Yep, we got our new NIC down here. All right, cool. So, where was that address? IPv4. Well, you're not going to tell me. Whatever. I just use the terminal. That 8.127. Okay. I think this is our wireless device. Let's go ahead and punch that in. Oops. Immediately mess it up. Yeah, I think this thing did. Let me get our device connected to this over wireless. Not now. All right, enable Wi-Fi. Let's see, modify. Let's see, Wi-Fi name, RFF. Lab. Good life. No, dog. How about robots? Yeah, there we go. Way better password. Super secure. Okay. Oh, it's gonna be minimum 8 characters. Robots. 99. 99 robots. That's awful. Horrible password. Never use that password. Whatever you do, do not use that password. Okay, so let me go ahead and get on our test phone. This bad boy right here. We're gonna get connected to our Wi-Fi that we just stood up. All right, and we will connect to that. All right, connected to device. Cannot provide internet. And that's good. I want to see if I can do, see what this app will do. That was another thing too, is I kind of wanted to pull this app off of the phone really quick and dig through that. Because I don't have internet for this thing, and I don't want to connect it to the internet yet. Yeah, I need to get that set up because I don't have the man in the middle set up for the for this device yet. So let me mess with that later. Let's go ahead and pull the APK off of the phone, and then we can test that and dig through that. We'll see what we can find in there. If there's anything interesting, but who knows? No, I don't have internet on the actual wireless device or the access point yet. And I don't want to configure it and connect it until I have man in the middle set up, because then I want to watch every single step that it does. And if we go and set it up, I'd just have to wipe it. And it just seems more bothersome. So do I have ADB on here? Okay, cool. Okay, let's USB. All right, ADB. What is it? Oh, I probably have to enable debugging. Let's see. USB debugging connected. Okay. All right, USB debugging is enabled. And let's see. Yep, always allow. Okay. So when you connect ADB for the first time, if you've never done this, it'll prompt you on the device to connect. Only implemented for libUSB backend. All right, well, let me see. What did I do? Oh, I need to use ADB shell. Okay. So, let's see, we're going to be dumping, and I'm following a tutorial because I cannot remember the steps to do this every time, but we need to use ADB shell, package manager, list packages, and this will tell us all packages on the device. And we are, let's see, grep for ring. All right, so this is com.ring app package, com.ring app. Okay, so let's copy this. We'll need the path to that. Or sorry, the name of the application. Then we'll do ADB shell, PM. Oh my gosh, I cannot type. Path. And then it's going to be com.ring app. And this is going to give us the path to it. And then we're going to want this base.apk file. So we'll copy the full path to that. And then we're going to run adb pull. And this will be the path to the file. And we're going to do ring app.apk. All right, and that should pull the APK file from the phone. And this is much more preferred than like, I know you can use like websites to download APK files, but I found that sometimes they don't have the app that you want for whatever reason, or sometimes it's the wrong version. So it's better if you have an actual device or an emulated device to do this to pull the actual APK file. And that way you can download the app from the actual App Store, the Google Play Store, legitimately, and then pull the real version from the Google Play Store for whatever device that you're testing on. So now we've got our Ring app. Yeah, there you go. We're just dumping on the rooted device. Yep. And this is a rooted device, but I think you can, if the device isn't rooted, you should still be able to do this with ADB, which is kind of nice. And then I'm going to use JetX. And let's grab this APK and let it chew through that. We'll see what comes up. Oh, running low on memory. Am I using all the memory of my VM? Yeah, kinda. Needs more heap memory though. Thank you. Yeah, there's a lot that I do know, and then there's also a lot that I do not know. There's so much stuff to know. Let me bump the memory up on this VM and restart it really quick. I've only got 4 gigs on there. Let's set it to 8192. We'll hit apply. Okay, and then we're gonna shut it down. Shut it down! Shut it down, you fool! Okay, and we will turn it back on. That'll boot itself back up. Okie dokie. Okie dokie. Alright, so let's get back into our directory. And I think we should have enough memory now. Let's see. Okay. Maybe 8 gigs total. Let's see if JADX likes that. Uh-oh. It's getting there. Oh no. 4.8 out of 5.42. Wow. You're really gonna want more than that, huh? Yeah. Okay, okay, okay. I'll give you more. I'll give you more. Jeez. What do you guys think? Memory just grows on freaking trees around here? Alright, let's give it 12 gigs. You think it'll like 12 gigs? 12 to 88. Shut down. Okay, while that's doing it, I want to adjust the chat. Been trying to get the placement on this thing proper for a while, and it's been driving me crazy. The chat window. Alright, let's see. There, I think that should do it. I don't know. Okay. It was driving me crazy, it not looking proper. But okay. Let's reconnect to this. Oh, I gotta turn it back on. Turn it back on, turn it back on. VM starts. Yeah, I still need to figure some stuff out with OBS, but that does look better. Okay, cool. Close that out, and I'll CD back into our directory. And then JADX, get JADX, JADX going again. And let's see what it does. Of 8 gigs. You should have more than that. Did I do it wrong? No, okay. Oh, it's only got a maximum of 8 gigs heap. So I have to start it with more heap. Even though I've only got 12 gigs now. I may have to do that. We'll see if it winds. Jeez, man. How much RAM does this thing want? Okay. Well, it's chewing on that, so that's cool. Well, let's try to do that. I'm gonna see if I can't get this thing open. I'll go hit it with a hammer. No. Hitting it with a hammer is the last resort. Oh, you know what'll probably work well? If I do both of these. Or not, I don't know. This thing is sealed up pretty tight. Are you done? Is it done? I mean, it looks done. Okay. Cool. All right, let's see what we got. Input files, ring app, APK, cool. Source code. Oh, geez. I don't like looking at that first. Let's look at, let's get our summary. Code sources. Got our native libraries, 44 of them. And I'm kind of an idiot when it comes to like Android stuff, so I'm still learning a lot of this. But I find it's fun to dig into it when I get the opportunity so that I can learn more. Where's our strings? I like strings. It's under static. Is it resources? Where's that gonna be all of our graphics and stuff? Yeah. Okay. Endpoint config.json. Oh, hey, that's fun. Client ID ring, US West 2, ring US West, prod key. So we'll probably want to see one of these things when we go and start doing man in the middle on the device. This will confirm whether or not we're capturing some of that traffic if we see some of this stuff. Oops, definitely not what I want. Open folder. Okay, this folder. And we want to open our juice. Oh, I already had it open. Wow. Ah, manifest. I like the manifest. Find some interesting things in here. Like API keys. That's interesting that they just have these right here. Bugsnag, Android API key. Ring app, host path prefix. So you might want to pull all of the prefixes, all of the paths, API paths out of here, and we can look at those just to see what it does. But yeah, digging through here is, we can look at like a lot of the static stuff, like strings and everything, to get a good idea of some of the things that it's doing. But a lot of this code is very very awful to look at and try to take apart. Let's see. And this is all going to deal with like the actual app itself, so maybe not connecting to the device over the network. But I wonder if there's anything like MQTT. I really want to get the device open because I want to mess with the hardware more. Ah! Oh, look at that. Killing the memory on it. Okay. Probably plenty of mentions of API. Open, damn you. Sorry, you guys can't see it, but I'm sitting here jamming a screwdriver into this thing trying to get it open. Identity auth device API. String keys cookies, key response URL, key association handle. Interesting. I wonder if that's related to like cookies that get set when those web requests to the API endpoints are made or whatever. Fire OS SDK. Amazon Identity. Yeah. It's probably related to yeah, there you go, sign in URL. Interesting. Okay. Ooh, Nordic Semi. Yeah, I wonder what kind of BLE stuff it's doing. I was messing with some BLE things not too long ago. It's be kind of interesting to see what it's doing. Looks like some typical Nordic stuff. Set up GAT servers. GAT characteristics. I don't know if this is all like built in. This looks like a library. BLE manager handler, external synthetic lambda, BLE server manager. Let's see, connect request. Let's see how the application connects to the device. Connect. This seems like a fun one. Let's see. Close all to the left of this one. Okay. So it looks like we've got a connect request class. Yeah, that's what I'm thinking too, is it's part of the Nordic Semi SDK. Maybe we can figure out where this is actually being called in the code. Oops. No, I don't want to look in there. Yeah, this is all occurring within that library, the Nordic Semi library. It's probably all the custom code that's done by the actual Ring app itself is not going to be under here. And I don't know if we're going to be able to find references to this directly because it's all kind of like gnarled and mangled because this is all obfuscated stuff. Like, see, string F564B is like really dumb. Wireless ID. That's not. I mean, there's probably still some interesting things in here. I wonder if we can dig through the comments. Maybe not. Or is that somewhere else? Source code. I thought JetX pulled the comments out for you. Let me see. Because if there's any like developer made comments that it pulls out, that'd be kind of cool. Those usually have some fun information in them. Doo-doo-doo. Oops. Yeah, that's a good idea. Seem to know a little bit about APKs. I'm kind of a noob with APKs. Where's our manifest? There it is. There was, let's see. Yeah, this is kind of what I was looking for, is Bluetooth scanning and connecting, because that could be interesting to look at while the device is like in an unconfigured state. I'd imagine it's just kind of in a waiting for the app to connect to it and configure it. You're talking about these actions, right? Doing stuff like that, like, these are queries. Oh, that sounds fun. Adding cheats to games. Also makes me wonder if, I've always thought like, there's games out there that have like dev consoles or built-in cheats, but they're just kind of hidden or disabled. You could probably dig into the APK and find those. Let's see, intent, send to, launch ring, image capture, SMS to. Oh, I wonder what it uses NFC for. That's interesting. I don't know why a security camera would need NFC for your phone. GLES version. Bind, get, install, refer service. Ring app main dashboard, my device's dashboard activity. I'm guessing these are like kind of like internal API endpoints, but for the application itself. Intent filter. Those are all the different intents that are available to it. Hey, it's been years since I actually went through trying to make some Android apps, but I gave up because it's hard. Java is a very hard language to work with, in my opinion. And I think nowadays most apps are made with Kotlin, or is Kotlin just the compilation language? I don't know. Main dashboard UI. Yeah, that's that was this one up here. Oops. Main dashboard. Yeah, there's shortcuts. It's some yeah. Looks like it's just this one right here. My device's dashboard activity. Okay. Let's see if we can search for this. Oh, hey, nice. Took us right to it. If you want to start getting into reverse engineering, it just depends on what you're interested in. I would just recommend start taking apart stuff, whether that be existing malware or hardware or software. You just find ways to take it apart and try to understand it. For example, like you can take there's some if you're interested in like binary analysis and doing reverse engineering on binaries, there's some things called tricrackmes, and those are they're like pre-built binaries that people make. Here we go, crackmes.1, I believe. Yeah, you can do these. Crackmes.1. They're basically binaries that people have put together they kind of emulate like a game that has like a CD key requirement or some sort of requirement that will prevent the binary from fully executing or fully running. And so the idea is to kind of statically and dynamically analyze it and then patch the execution so that you can get this thing to either work without a serial key or work without a password, or whatever the actual challenge is. So you could do these if you're kind of a fan of like hack the box sort of challenges. These are a good way to get into like binary analysis. Or you could just start taking apart binaries that you find. Nothing to stop you from just like finding a binary on your system and trying to reverse engineer it and figure out how it works. But that's always a good start. If you want a hardware recommendation, I would say just find any old piece of hardware that you have in your house that is kind of old that you don't need anymore, and see what you can figure out about it. Whether that's like identifying things that are on the board, or finding ways to get like a console or a shell on it. And I would recommend, if you want to do like hardware analysis, like black box hardware analysis, is to find something that makes like wireless connections, and then check out the FCC ID label on the back of that. And then you can, oops, no wonder that's not loading. Hold on. There we go. We're all connected to my fake network. Sheesh. Okay. So yeah, you can find a piece of hardware that makes some sort of wireless communication, and then look on the back for like an FCC ID label, like this thing. This thing's got one on the back. Well, it had it on the inside. I had to pull it off, but there's an FCC ID number on this. And you can take that and you can stick it into fccid.io, and that'll give you some documentation where you can look at like the internal photos of the hardware itself and start looking at like the board level view. And then from there, you can identify things like test pads and ports and stuff for debugging. Like these little headers right here, those are usually a good indication of debug headers or test ports. So if you get your hardware open, you can actually start probing those and figuring out what those actually do. So that's a good way to get into hardware analysis, is to just start taking stuff apart. Don't be afraid to like, get in there and take it apart and kind of look at it on the board. If you don't want to take it apart, in my case, I can't get this one apart. It's been annoying. But if you can't get it apart, or don't want to take it apart, you can do this, and that'll actually give you kind of a good idea of what's inside, without having to get in there physically. So that's kind of fun too. So this is our My Devices dashboard activity function. Let's check our imports. So we're importing Ring App, Android Architecture View Model, Dummy View. So the view models, that's the actual stuff that gets shown on the screen. Yeah, go for it. Yeah, I have like a box of hardware that's sitting next to me that I want to take apart and kind of tear into and just figure it out. Whether you're looking for exploits or not doesn't really matter as long as you start asking questions about it. You're like, okay, what does this chip do? What does that chip do? Can I find a block diagram for this chip? And can I access the UART port on this one? That kind of stuff. Hamburger menu fragment. That's gonna be our settings menu. I don't know what the hell this is, but get screen ID, get layout ID. Oh, this looks pretty meaty. Okay, so this is on our create function. Yeah, I'm not seeing anything interesting so far. This is all just like kind of setting up the view. Bugsnag, network security config. That's an XML file. I wonder what's in there. Is that actually a file that shipped with this? Or is that just kind of like one that gets configured when the device is configured? Alarm monitoring devices feature? Modular setup, smoke alarm. Acoustic detection. What's in this big ass file? Oh, geez. What is all of this? So it just looks like a bunch of definitions for stuff. Oh, gotcha. Yeah, references. Oh, geez. Okay. It might be useful if I knew what I was looking at. Yeah. Okay. We can come back to that if it's useful later. Bluetooth low energy, Android hardware. Ring app, dynamic. Am I just looping? Actually, feature, no. Okay. Motion snooze. Yeah, I honestly have no idea what the fuck I'm looking at. I dig around in this for hours and not really find anything. I'd have to like find something targeted. I need something to look for. Let's see. Oh yeah, that's not a bad idea. Pass through the internet connection over ADB. I haven't done a lookup for those API keys yet. Those kind of seem like external things. Talking to the let's see, key. Yeah. Because this one's talking to Bugsnag and this one's talking to some contentful, whatever that is. I hope there's nothing crazy behind those API keys. Well, nothing, no hits on that. Let's see if we can get, are there any more ring.nh, nh feed, nh app? I don't know, I'm not sure what nh means. Oh, neighborhood. Okay, ring neighborhood. Okay. That makes more sense. Yeah, so this is probably access to the ring neighborhood. So com.ring.nh is ring neighborhood. All right. I'm really interested in like how the app talks to the device. Let's see if we can figure out where it uses this permission. I wonder if that's a thing, if we can just... So this is just looking for the permission. Ring app streaming, .service audio focus. Okay, now it's just checking to see if we have Bluetooth. Let's see about this one. See if we have Bluetooth scan permission, because that might be interesting if there's a function that's doing Bluetooth scanning. Yeah, it could just be bad. Izoni. That may be why it doesn't come up with anything. Yeah, this one doesn't come up with anything either. I am just looking through code as well, so if there's like a let's try comments too. Nothing. Bluetooth connect received. Ooh, received boot completed. Permission Bluetooth admin. Ooh, admin. Scheme HTTPS. Oh, I did do that. Let's did that not too long ago. Let's see if I still have it. Nope, I don't have it. Okay, whatever. Oops. Let's get some regex. Let's see. Scheme equals HTTPS. And where else are we? Nope. Oh, that's an interesting idea, modifying it. Modifying it and getting more permissions. Yeah. Hmm. HTTPS, whatever. Let's get this. Scheme. Oh, am I not doing multi-line? Oh, spaces? What the hell is all that? Is it just like one new line? Whatever. We'll just do that. I am so confused why this is not working with my new lines. Welcome to the stream where you can watch me struggle with regex for 30 minutes. Okay. Oh no. I refuse. It's usually just some stupid freaking transparent character. There we go. Holy shit. That's so annoying. Let's see. Make that a capture group. And we have another new line. And then let's see. Dot plus path prefix equals quote new capture group plus, and close that. And then we want to, let's just do that real quick. I think that's good. Let's see, and then we will do find and replace. Oops, do that. And, oh, I need to make it capture everything. CKMS URL. It's like a check MS URL or something. I don't know. I'll see. It's interesting how they've got the app G, app S, and app v3 as path prefixes for their API. I wonder if I can use like inetsim to emulate my notepad. Oh yeah, this CKMS. Oh, it's a key management server, probably KMS. That's yeah, certificate key management server. This would be like device management or manifest. Oh yeah, there you go, manifest management server. Yeah. Oh no, you're good, Azani. I'm kind of just bumbling around until I find something fun, something interesting. It's always a good opportunity to practice and play around. I'll smack my head against regex some more. It doesn't look like there's too many other HTTPS endpoints in here other than these. I could just copy these out. I don't need to get all of them. I don't need to pull all of it as a fancy thing. Let's come over here. And we'll paste this here. So now I've got these. If we want, we can rebuild these later. I was thinking with iNetSim, it'd be kind of interesting to get this device hooked up. I haven't used iNetSim in a while. I wonder if that's yeah, it's been a minute. Yeah, here we go, HTTP, HTTPS. So we could probably set up iNetSim and get the device talking to a fake Ring web server. That could be kind of fun. That would be a decent way to man in the middle it, unless it's got like certificate pinning. If it's got certificate pinning, then our traffic isn't gonna, we won't be able to decrypt the SSL traffic. Unless they did something stupid, which is always the case. Yeah, they could just do something stupid and not actually encrypt it properly or whatever. I don't know. So that would be interesting. I do want to man in the middle of the device and kind of watch the network traffic, but I also still want to like open it and get a look at it. But I don't know. Let's see. How long have we been going? Going for about 2 hours. Let me actually go take a break really quick. Gotta go to the bathroom. And I will be back in just a couple minutes. Free MITM proxy. I've got man in the middle proxy. I could use that. Which I had set up for some previous engagement that I was doing before I started this stream. But I probably want to configure that along with iNetSim, because what iNetSim does is it simulates like your HTTPS server and all this other stuff, and so that it gives the device something to talk to. Whereas if I had man in the middle set up and it was connecting to like Ring's actual web server, excuse me, if it was connecting to Ring's actual web server, the traffic would make it through, and if it was encrypted, I wouldn't be able to see any of it. If I did iNetSim and man in the middle it, if it was encrypted, I'd at least be able to see like what it was trying to talk to and everything, all the other devices. I mean, I guess you'd be able to get to see that either way, but I don't know. I have a feeling that if I used man in the middle proxy, it would work. But it's gonna be encrypted anyway, because most modern devices use certificate pinning, which is where they store a certificate on the device, and that prevents it from actually, picking up your network cert. So it's got its own certificate chain that it relies on, and that keeps it from divulging secrets. But yeah, let me take a break really quick, and I'll be back in a few minutes. I'll give you guys some music to listen to. Okie dokie, we back. Thank you for waiting. So, let's see. What the hell was I doing? Talking about, iNetSim. I was also thinking it'd be really funny if I could get this thing, to the point where I just have it on LAN, and it acts as kind of like a webcam for my stream. Because I do need a device for part cam, or like the desk or something like that. Right now my camera's doing double duty, and it's no face cam. Wow, that is a pretty crazy setup. Clash of Clans API. I'm gonna dump their encrypted cert. Yeah, that's pretty wild. That tends to be the case with like cert pinning, is you have like a device certificate. Um right now I managed to grab a hold of that little gasket, so I'm pulling that out. Maybe that'll make it easier for me to get this thing apart. Yeah, with certificate pinning, there's oftentimes like a device cert that is unique to the device that's generated on the fly at boot up. I've seen it with routers, where they will like grab the serial number from the device and they'll use that as a as kind of like a salt when they generate their certificate, and then that certificate is generated against like the CA or some crap like that that allows only that device to talk to the API. Um, so you could, so if you really wanted to like talk to the API, it's not. I mean, I guess it is much more secure, but you could just grab that certificate and use it yourself, like after it's been generated. But it does prevent you from like sniffing the traffic between the device and the API. And it also prevents the issue where there's like a master certificate that gets leaked or something like that. Because like if you in the instance that you pull a certificate from the device and you go and you use that certificate to start talking to whatever API it is, um, if you don't do device unique certificates, then that stolen cert can apply to the entire API for any device or any attacker. Whereas if we have device specific certs, that cert only applies to that one instance of a stolen cert. So it is more secure to do it that way. Prevents like a larger exposure if one piece of hardware gets popped, so to say. I just want to open it. I swear, I feel like there's a screw that I'm missing or something. Oh my god, there are. I'm so stupid. Holy shit, I'm so stupid. Alright, guys. Excuse me for being absolutely stupid. Oh my god. Holy shit, I'm missing screws. I've been fucking jamming spudgers at this thing for the past hour. Holy shit. I need an extendo rod. That's not gonna work. I can't get my screwdriver down there. Alright, hold on one sec. BRB. Getting this shit open. Okay. Let's see if the Extron tweaker will get down there. So I don't know if you can see it, but right down there in the corner, right down past there, those are 2 screws. 2 screws. Let's see if I get these suckers. Wow, they're in a horrible spot. Oh my god, that's awful. Yeah, it's all kind of the same thing. It's like black box reverse engineering, where you really don't know a whole lot about it. There's not, you don't really, none of it's really documented, unless somebody has already gone through the steps in the past and documented what they're doing or what they discovered or saw. It's kind of a black box. So you have to use a combination of like static and behavioral analysis and various techniques and tools to like probe the system, whether it be a game or a piece of hardware or a piece of software. Use those techniques to probe the system and get feedback, and eventually you start to understand how it works, and then you can manipulate it and do whatever you want. Wow, those screws are so deep. Okay. Be right back. Let me go into my lab and grab another screwdriver. This one will do it. Welp, they got me. Amazon Ring has foiled me with their very deep screws. They're so deep. Why are these screws so deep? Yeah, I have no doubt you could do that kind of stuff with the man in the middle proxy. I will admit that I am not super good at man in the middle proxy, and I could stand to learn more about it. So might try to do that later on down the line. Once I get this stupid thing open, holy crap. I really just want to like put some wires on it. Okay. Cursed device. It's a cursed device. Let's see. How can I run IDM proxy? Let's go read some docs. I like to read me some docs. Because I should be able to, I believe, with this little router I have, I should be able to hook that up with proxy. Wow, okay. You're not actually going to connect, are you? Well, but still thinking about it. Because I think I should be able to... No, I don't know if that works like that. Because if I'm running man in the middle proxy on this host and a wireless router outside that, ooh, yeah, that makes it a little bit tricky to be like, hey, route all your traffic through me. Oh, it's got a gateway mode. Okay, that makes more sense. Yeah, that's what I need to do, is I need to configure, like you're saying, set it up as a gateway. And then have that gateway available, or force this wireless router to go through the gateway. So I think that's probably what I need to do. Let's see what this does. Let's see if it'll actually connect and let me configure it. And then maybe I can Oh, that's why. I've got that plugged up as the WAN. No wonder. Hello, router. Doop-a-doop-a-doo. Any day now. Okay. Let's try this one more time. We'll be slow. We'll let it do its thing. Think about it. I'm gonna have to figure out how to get this open. I'll have it open on next stream. Probably stream Thursday or so, Thursday or Friday maybe. Kind of dive into this a little bit more. Hopefully have some board level access to it. Because that's where I really want to play around is the board level stuff. Let's see, are we connected? No? Oh, okay, cool. Yeah, okay, there we go. I think the thing was still trying to turn itself on the router. That is. Oops. Cannot type. Okay. Okay, no cable connected in WAN port. Man in the middle proxy. Let's see. That's right. I'm gonna read the docs. I want you in gateway mode, right? That's what you were saying. Oh, of course, it's not gonna find it because I'm not connected to the network anymore. Yo, what's up, Patrick? The good kind of juice, you know. That good juice. Let's see, man in the middle, gateway mode. Options command, let's see. So, is that man? No. Is it? Oh, options. Oh, commands. Show all commands with their signatures. Yeah, I want to learn a lot about MITM proxy because it's pretty big with a lot of IoT pen testing, which is pretty fun. So it would behoove me to get better at it. Hello, Vic. How are you? Oh, transparent proxy. Okay, yeah, that makes more sense. I am familiar with transparent proxies. So I've got HA proxy configured as a transparent proxy in my lab setup. Okay. Let's see, MITM proxy transparent mode. Oh, that's interesting. I wonder if I can use WireGuard for that. To route all of the traffic, because this little gateway or this little wireless router that I'm using has a WireGuard mode. Yeah, this is I pulled the Ring app off of the off of a phone that I've got sitting here, this phone, and decompiled it with JADX. I don't know what any of this means, but but I can dig through it, and I've been digging through it, and kind of there's some interesting stuff. There's some API keys, which are kind of fun. Oh, here, look at that. There's the Bugsnag. That was one of the API keys. But there's some interesting things in here. But I haven't dug too much into it to figure out what all of it means yet. I'm drinking water at the moment, Patrick. I got done with my tea. So, well, while I'm trying to figure this out, I don't need network on that. Okay. We'll do transparent. Transparent proxying. Okay, so let's see. Now we're gonna turn off our redirects, set up forwarding, IP tables, MITM proxy. Okay. Yeah, so I don't want to. I believe I want to set up this. Yeah, that's interesting. Let me. Oh. Dev Krita? No? Okay. I thought I had Krita on here. I guess not. I was gonna draw a little diagram. Because this will have to be something that I set up to actually test this device. I do have this though. I can use this as my little diagram thing. Let's see how well this shows up on the camera. All right, cool. So I want to, let's just say this is our device. I don't know, I'm a horrible artist, so get ready for that. And then we've got, let's see, this is our internet. That's our internet right there. Oh, our device is right there. You can't even see it. There we go. So this is our internet. This is our device. We want our proxy to sit kind of right here, and have our device go through the proxy and then go to the internet. But the problem is that my proxy is sitting over here on my VM. So, and I want this is kind of the this device right here is the router. And this is our actual camera. So if I have the camera connected to the router over wireless, but I want the router to actually be a transparent proxy that my VM is kind of supplying to this, and then it's going out to the internet. That's kind of like the infrastructure that I want. I think that would work. Because then all the traffic that comes in from the device comes over here, it goes through my transparent proxy, and then gets shipped out over towards the internet, if that makes any sense. Yeah, that's a good point. I do have on this device that wants to open up, I do have PCAP Droid, and I do have man in the middle proxy on here. So I could connect the I could connect the phone to man in the middle proxy. But see, that's why I'm thinking if it's the router, it's better because I'll have the phone connected to the wireless router, and then I'll have the Ring camera connected to the wireless router, and all of that will be proxied through man-in-the-middle proxy that's running on my my attacker VM. Because then I don't have to worry about connecting to the proxy on either of those devices. It'll just be running on the router, or at least the router would be, you know, feeding it through. Feeding all the traffic through the proxy. So that's kind of the setup that I think I need to do. That's our Kali VM. And the net. Horrible diagram. But I think that's kind of the layout that I need to get set up to properly proxy this. There's a bunch of guides online that I've seen that that will have, you know, walkthroughs on how to set this kind of architecture up. But it takes a little bit. It's a little fiddly. So I might set this up and then come back next stream, either Thursday or Friday, and then we'll have a process set up to like capture the traffic between this thing and my phone and the app that's running on it. So because I think we're coming up on what 3 hours, 2.5 or something. Anyway, yeah, I think I'm gonna go get some food, and I will approach this later. Yeah, okay. Yeah, Friday, Thursday or Friday. I'll probably end up doing it Friday, depending on what I'm doing on Thursday. We'll see. I tend to do most of my streams on Tuesday and Thursday, but I don't really have a set schedule yet. But I think Friday most people are free for a couple hours in the afternoon, so that tends to work pretty well. But yeah, thanks for hanging out, everybody, and I hope you guys learned something. I definitely learned a couple things, and we'll pick this up later and hopefully learn some more. Bye.